Hello, we are doing 5.5 today, which is our start with factoring. Okay, but here we're going to start off with just greatest common factor and factoring by grouping. Okay, so these are two factoring methods that we're going to be looking at. Okay, so take notes, have your phone ready in case you have questions. So, greatest common factor, GCF, and factoring by grouping. This barely fits. Okay. So keep in mind that when they ask you to factor, um, so to factor, really, it just means to rewrite as a product multiplication. Okay. So the first way we're going to look at factoring is by GCF. So factoring by greatest common factor, GCF. Okay. And this is something, as we learn other methods for factoring, this is one that you always want to check for. You always want to check to see if there's any common factors before you start any of the other kind of factorings, because if you do have a greatest common factor, GCF, then when you do this kind of factoring, you are able to make the numbers smaller to work with. Okay? All right, so always check for common factors. Always check for common factors before using other factoring techniques. Okay. All right, so let's take a look here. All right, let's go ahead and factor the following. Okay, suppose that I have this 16y squared plus 24y. So what I'm doing here is really trying to work backwards from the distributive property. It's kind of like you're trying to figure out what got distributed to give you this answer. Okay, and the way you figure it out is by looking at the two terms and trying to find what they have in common. Okay, so you can start with the numbers 16 and 24. So what's the biggest number that they have in common? The biggest number that can go into both of these, 16 and 24. Okay, so hopefully you see 8. If you don't see 8, let's say you saw 4. Well, that would be fine. Okay, so that would be fine. So what you want to do is whenever you do common factoring is always check to see if what you have left inside the parentheses, always check to see if you can factor some more. That way you can kind of verify that you found the largest number. Okay, so the largest number is 8. Okay, let's suppose we didn't see the 8. Let's suppose that you guys saw 4. Okay, and then they also have a y in common, but only one y, because you have 2 here, but you only have 1 here. So they only have one y in common. All right, so you would factor that out. Okay, and then you would try to figure out what goes in here to get this back. So you have to ask yourself, 4y, this is your common factor, 4y times what will give you that? And that would be 4y. 4y times 4y will give you the 16y squared. And then you ask yourself, what should go here? to get 24y. 4y times what will give us 24y? And that would be 6. Okay, so this is what I mean by checking your final answer before you think you're done. Because if you didn't get the greatest common factor 8, then it'll show up here. Okay, it'll show up that you still have something in common. And we can see here that, oh, I'm not done because they still have 2 in common. So let's move this 4y over. All right, so over here, if you factor out 2, then you'll be left with 2y plus 3 on the inside to get back 4y plus 6, right? And now they don't have anything in common, so we are done. So here, I can multiply the 4 and 2 out here, and then you can see that you will get the 8 even if you don't see it initially. If you don't initially see 8, if you make sure that you factor until you can no longer factor, you'll eventually get the 8. Okay, so if you can only find a common factor, that's fine. Just start with that. You'll get smaller numbers, and then you'll see whether or not they have anything in common, and you can just keep factoring and factoring and factoring until you can no longer factor. Okay. All right, let's take a look at this one. 25a cubed b minus 15ab cubed. Okay, let's start with the numbers, 25 and 15. So they have 5 in common, so we're going to factor out a 5. If we look at this, they both have a, at most 1, because this only has 1, but that one has 3. So we can only factor out 1 because we're looking for common factors. And then same thing with the b's. This one has 3, but this one only has 1, so we can only factor out 1. All right, so now let's go ahead and figure out what goes in here to get this back. So 5 times what is 25? 5 times 5. Now I have a here, but I need 3. So a times a squared, because remember, we have 1 here. 2 more will give me 3. B, I already have a b, so I don't need any more b's here. Okay, and you can check. If you multiply this out, you get 25 a cubed b, which is what we have here. Okay, and then over here, 5 times what is 15? 3. We have 1a here, and we only need 1a, so we don't need any more a's. I have b here, but I need 3, so I need b squared to make b3. B times b squared is b3. Okay, and again, you can check, multiply, you get 15a b cubed. Okay, and then check to see if you can factor some more. We can't. The numbers don't have anything in common. So this is my final answer. Okay. All right, let's take a look at this one. Suppose I have 3x y squared z cubed plus 6x y z cubed plus 3x z squared. Okay, so let's begin with the numbers. 3, 6, 3. So the common factor there is 3. So we'll be factoring out a 3. And let's check, do they all have x? x1, x1, x1. So we'll be able to factor out x1. Do they all have y's? This one has y squared, y1, no y. So we cannot factor out a y, okay? Because all of them have to have it. This one doesn't have any y's. Okay, so what about z's? This has z cubed, and z squared. So the most we can factor out is square. All right, let's figure out what goes in here to get all of this back. So let's start here. So we have 3, we have x, we need a y squared, and we need 1 more z. And if I multiply this out, I would get 3x y squared z cubed. Okay. Over here, 3 times 2. I already have the x. I need a y, and I need one more z. And if I check, 3 times 2 is 6. And then I have x, and I have y, and then I have z squared times z1 is z cubed. Okay. And then over here, 3 times 1. I don't have to put the 1 though. And I already have the x, and I have the z squared. So actually, all of this, 3x z squared is here and here. So it's actually, now I do have to put the 1 because there's nothing else left. Okay. All right. And they don't have anything else in common inside the parentheses, so I know I am done. Okay. What about this one? What if I have this? Do they have anything in common? Did you say 3? They don't have 3 in common. Okay, they don't have anything in common. So we say this is prime. Just like prime numbers, like 8, you can break that down as 2 times 4, right? But if you look at 7, you can't. So 7 is prime. Okay, same thing with this. You can't break that down. It's prime. It's not factorable. Okay, so let's take a look at this one. This one will be kind of interesting. This is one term, and this is another term. Okay, so this group is one term. This group is another term. What do they both have in common? Do you notice that they have this group and this group both have x plus 1. So that's what I'm going to factor out. I'm going to factor out an x plus 1. So if I take this out, I'll be left with x plus y. Okay. Let's see if you can see it with this one. Suppose that I have this. A times x minus y plus z minus b times x minus y plus z plus 3 times x minus y plus z. So now I have 3 groups. I have this group, and this group. What do these 3 groups have in common? X minus y plus z. Good. So I'll factor out x minus y plus z, and I'll be left with a minus b plus 3. It's what you have left when you take these out, right? Because you factored it out. So you'll be left with a minus b plus 3. Okay. All right. So that is leading us into factoring by grouping. Okay. So that's GCF, greatest common factoring. Okay. So factoring out what they have in common. So now we're going to look at factoring by grouping, which is GCF, but you're doing it twice. Okay, so we learned our first graph factoring technique, that's GCF. So here's your second factoring technique, factoring by grouping. So we usually use this when there are four terms. So this is usually done when there are 4 terms. Not always, but usually. Sometimes it's done when you have 3 terms, but typically it's done with when you have 4 terms. Okay. Before you start this technique, always check for common factors first. Okay. So, and I said that way up here. I said, always check for common factors before using other factoring techniques. Okay, so this is a new technique. So we're always going to check for common factors. before we start this technique of factoring by grouping. All right, so let's take a look. So suppose I have to factor this, 2m minus 2n plus mn minus n squared. Okay, so I have these four terms, right? So what happens is it's called factoring by grouping because you're going to break them up into groups. Okay, so 2m minus 2n, these two terms, this is one group. And mn minus n squared, this is your second group. Okay, so what happens is I'm going to work with this first group. Okay, so this is your first group, and you're going to just do greatest common factor. Okay, so it's like you're going to ignore that. Okay, and all you're going to do is with this group, you're just going to do greatest common factor, GCF, and they have 2 in common. So I'm going to do this. Okay, that's all you're doing. Okay, let me go ahead and bring back the other two terms. Okay, so you're done with that first group. That's why we call this factoring by grouping. We group them into two groups. That's the first group. We do GCF. We're done with this group. Okay, let me write down the other group. Okay, and so now we do GCF with this group. Okay, see the sign right over here? Whatever sign that is, that's the sign you got to bring down here. Okay. All right, so here they have n in common, and I need m minus n to get that back, right? Okay, so now I've finished doing greatest common factor with my second group. Okay, this was my second group. Okay, so let me bring back the first group. 2m minus 2n. Okay, so this was the original problem, right? This was my first group, and I did GCF. This is my second group, and I did GCF. Okay, so that's all you do for your first step. One group, GCF2. Second group, GCFN. And if you do that first step correctly, then you'll see here the parentheses should match m minus n and m minus n. So this group and this group have m minus n in common. So I'm going to factor out m minus n. And if I take these out, I'll be left with 2 plus n. And that's what goes inside the other parentheses. And that's it. There's your product. Okay, once you have it written as product, then you factored. Okay, so let's take a look at another example. Okay, so let's go ahead and factor 5x cubed minus 8, okay, plus 10x squared minus 4x. All right, so this is my first group. This is my second group, right? So let's start with the first group. Greatest common factor. They don't have anything. If they don't have anything, then just use 1. And just factor out a 1. Okay? All right. Second group. Plus sign, right? This is a plus sign. There will be a plus sign here. Okay. Here they have 2 and an x in common. So I'm going to factor out 2x. And I'll be left with 5x minus 2. Okay? All right, so I have this. So here, you'll notice, okay, well, they don't really have, these don't match. So you might be thinking, oh, okay. You might be thinking, oh, it's not factorable. Okay, this isn't necessarily true. Okay, so if your parentheses don't match, just make sure you go back and check to make sure you did do the GCF for each group. Okay, if you did do it correctly and you did this group correctly and they still don't match, then what you can do is check to see if you can rearrange these. Okay, so let's see. If I rearrange them like this, so try rearranging the four terms. So the original four terms. Okay, so if I rearrange them, so I have 5x cubed plus 10x squared, and then I have minus 4x and minus 8. Let's see what happens if I do that. Like I group the 5 and the 10 together, and I group the 4 and the 8 together. So that's how I decided on this. Okay, so if I do this first group now, okay, then they have 5x in common, no, 5x squared in common. And then I will have x plus 2 here. This group, okay, here this has a subtraction. That's going to be an important part. Okay, so here they have 2 and 4 in common. Okay, and so now it's more like a negative 4. So negative 4 times x, and negative 4 times what to make negative 8? It has to be a plus 2. Negative 4 times positive 2 is negative 8. Okay, so that's why be careful when this is a subtraction. Okay, and you'll see, okay, if you didn't do that, if you didn't change the sign and you went with negative 2 because this is a negative, you'll see these don't match. And if you're off by the sign, check here. It's probably because you didn't use your negative 4. Okay. All right, so here it actually does work. So they have x plus 2 in common, so I'll factor that out. And when I factor that out, take this out, and I'll be left with 5x squared minus 4. And that's what goes inside here. Okay. Okay, so if it doesn't quite work out in the order that it's in, then try rearranging the four terms. Okay. All right, I want you to try this one to make sure that you guys have this down. Try this. Factor x squared minus bx minus x plus b. Okay, and then hit the pause button and come right back. Okay, so here, x times x minus b, and then here, that's going to be a negative. They don't have anything in common, so I'll use a 1, and then I'll have that. The parentheses match, so that's what's going to go here. If I take this out and take this out, I'll be left with x minus 1. Okay, so if you got this, then you are correct. All right, so that is it for 5.5, part 2. If you have any questions, make sure you email me or text me.